I remember in the 90s, I was working in New Zealand. I was attending Waikato University and took classes with Ian Witten about text compression. And I was bored in class, and he noticed and took me out of his class and put me into his lab and asked me to do stuff that was more interesting. And so the task that he gave me was to identify grammatical structure in language without knowing what language I was looking at. So I compiled a large corpus of hundreds of millions of words, and I got the largest machine at the university, which had 2 gigabytes of RAM, which was amazing.
Woohoo!
And then
Wow.
I wrote a C code that would use that RAM as efficiently as I could. So I really split up my input at the level of less than a byte to squeeze as much into memory as I could. And then I parsed everything and translated this into tokens and threw out all the tokens that were very rare. And then I did statistics over these tokens. And instead of just using n-grams, which look at adjacent words, I looked at pairs of words that could have quite a distance from each other. And I would try to find out how well words predict each other pairwise. So in both directions, if you have a pair of words in the same sentence or paragraph. And then I would try to construct a tree-like structure that would put the words in the order that allow you to make the best prediction over the text, which is the best text compression. And it turned out that this tree that you find over the structure in the sentence is capturing semantic relationships. And it's capturing grammatical structure. And it's going to capture the different grammatical structure for different language.
Okay.
Now, the next step is that you, by doing these co-occurrence statistics, you split these different similarities or co-occurrences of words along different dimensions. And this allows you to create space in which you embed the word. So every word is going to have a position in a certain space. And it turns out that the directions, the dimensions of that space correspond to semantic relationships. So for instance, there is going to be a vector that you can construct between the words king and queen that is very similar in distance and direction to the vector between the words man and woman. So basically in this high-dimensional space, there is going to be one direction that captures a grammatical or semantic relationship that is pretty much gender, right? So you can use this to make inferences. And while I did these things, I found that it was very hard computationally and for the algorithms that I was using to go higher than pairs of words. And I wanted to go in basically arbitrary levels of relationships, maybe fourth-degree relationships and so on. And I wanted to go beyond the context of a sentence. And this was very difficult with the algorithms that I implemented and tried. And I thought if I had a much, much larger machine and could work in parallel, maybe I could use a large context and basically test the relationships of everything with everything in that context and do my statistics over there. And when I read about what the transformer was doing in GPT-3, this is pretty much the solution that they're looking for, right?